Okay, so grand finale is here. So it's the first time they put me actually in the last slot, so to keep some of you guys interested all the way till the last presentation. Sorry about that. It's the first time I feel used myself like that, so but let's start. So last year I started a series of presentations that covers stuff that basically annoys us at the support the most. So with a big purpose to reduce the amount of emails that you send to us. Yeah, so it's a self-serving. Make no mistakes about it. So this year I tried to continue on the same way, but there was lots of random stuff that I really struggled to put in the same presentation, so I have to come up with some concept that you will see through. But basically we will talk about most underused MikroTik hardware and software features. And the alternative name for this presentation could be the path between fastpath and advanced features. So objective is very simple, to allow you to understand that you can combine fastpath and slowpath features. Next objective is to allow MikroTik equipment to do more than maybe you utilize right now. Encourage you not only to upgrade router OS versions, but also update your existing configuration, because sometimes simply putting the new version on doesn't achieve anything, and sometimes even breaks something, but sorry about that. And of course, as I already stated, to reduce the amount of hardware performance issue emails to the support email of MikroTik. So plan is very simple. We will talk about most popular performance issues and mistakes in a hardware choice, in hardware usage, in layer 2 feature usage, and layer 3 feature usage. So, and I will try to give you all the information necessary to avoid such problems. So let's go into this. So knowing your hardware, basically, or using the wrong hardware for the job is by far the most popular mistake that we've seen on the support email. So, and MikroTik devices are special because we try to give you all the functionality that we squeeze out from that chipset. Sometimes even when we create the device, we don't know how will you use it, because we don't have use cases, but this device, this chipset supports it. So let's add that feature. Maybe somebody will find something that's useful. So each of our devices have unique structure, like CPU cores, like memories, like port interconnections. And of course, each device, each chipset have a different performance. So switching performance, bridging performance, routing performance, or encryption performance. So to help me out, I introduced this guy, meet Dave. So he's a smart, experienced network administrator. He's well certified in all the major equipment brands. And as it sometimes happened, there was a major disaster and his main router died. He needed to fix something now, and to order equipment, he had to wait for a few weeks. And the only spare equipment he was able to find was 750 GR3. That some friend went to some kind of event, with some company, MikroTik, and gave him let's try this out. This is really good. So he had no options. He tried to give it a try. So he needs MPLS, L2TP with IPsec, some firewalling, and some routing. So a few days later, 750 is working just fine. It fixed almost all the problems that Dave had. He's in shock that $60 box can really do all these things. He starts to discover all the router OS features, starting to become a fan, starting to use wrong logos for the t-shirt. And this is the moment when he tries out, does these people at MikroTik really exist? So he starts to write to support. And not only one email. So, of course, Dave encounters problems. So Dave's problem number 1. He has a daily database exchange, and that throughput is limited to 1 gigabit total, not 1 gigabit full duplex, as he expect from 2 different gigabit ports, but from 1 gigabit full duplex, and CPU is 100%, and he's just routing large packets. Why this is the problem? So why he can't reach the wire speed between these 2 ports? And the answer is he never looked at the block diagram of 750. And the reason behind the problem is Dave uses either ports either 2 and either 4. And if you go to our router board or product page, you will find out that on 750, there's CPU with 2 gigabit line connection. And first, third, and fifth port by default is connected to the 1 gigabit line, and second and fourth share the other gigabit line. So you can't get from second to fourth 1 gigabit full duplex, only 1 gigabit total. So in this case, half duplex. So what Dave needs to do is to simply replug one of the cables of most actively used connection to other port, and voila, he has full duplex. So, and you can't even imagine how many emails we just reply, please use different port on the board. And that solves the problem. So, of course, that didn't end there. They've had more problems. So, problem number 2. Now he read that there's such a switching option, or the hardware bridge option in 6.41 that we announced. So some of the Dave's ports that were bridged now are switched, and he again dropped the speed to 1 gigabit per second, half duplex, so can't get the full duplex speed anymore. And there's another diagram for 750 GR3 when you use switch menu. So this happens. One of these 2 lines from the CPU get dedicated to switch. And all the remaining ports are left on the other 1 gigabit line. So also useful change to know, don't you think? But OK, how many of you were aware about this? 4 hands. 5. So yeah, you can see where the support ticket emails arrives and where is the problems coming from. It's not a secret. It's publicly available information. Simply nobody uses it. So basically, to solve his problem, Dave just needs to go back to the simple bridge instead of switching, and he will get his 1 gigabit line back. But of course, things move, and you cannot leave 750 just hanging in your main server room next to racks and say that this fixed all the things and this is permanent fix. You need to improve on that fix, so you need to get some additional device. So Dave needs more ports, and he decides to replace 750 for 3011. He needs more switching throughput. He examines the block diagrams, so he is now aware of block diagrams. He examined the block diagrams for bottlenecks, and of course, at this point, he's even more enthusiastic and keeps writing to support@mikrotik.com. So if we take a look at the block diagram of 3011, you will be able to see that there's 2 gigabit lines to every switch chip, so first 5 ports and the second 5 ports. But as soon as you plug in SFP module in, one of the gigabit SFP ports will just be dedicated to SFP, and these ports over here will be limited to 1 gigabit per second. So, and of course, Dave runs into the problem. Dave's problem number 3. His L2TP plus IPsec connection getting overloaded. CPU is 100%, throughput is down, but 3011 is bigger switch. It should be much more powerful. So what's happened? So you can diagnose this problem by looking at performance tables of both devices. And the reason why 750 performs much more better is because 750 have encryption chip on it. So hardware encryption acceleration exists on 750G, but currently it doesn't at 3011. And if you go to the same product page, you will find there is a performance tab where you can find performance tables like these. So this is simple performance tables. So for example, like 750 can do 1 million packets per second, small packets per second. 3011 can do 1.5 million packets per second. You can see, basically look at all these metrics if you want. But if you take a look at IPsec performance, you will see the obvious thing that 3011 doesn't have this table there, because those numbers are very small and there's no point to showing you them. So hardware accelerated 750 GR3 can actually handle up to 500 megabits with a single tunnel and this encryption over there. So that is the reason why 3011 upgrade didn't work for Dave. He didn't look at the performance tables. So now Dave is getting smarter. He examines performance tables, IPsec acceleration tables, also the diagram, and he decides that he will replace 750G with 1100AH X2, the old one. So he also examines block diagram, switching bottlenecks, and decides that best ports to use on this device is 11, 12, and 13. So if you take a look at the performance, you will be able to see that by the small packets, it's 1.5 times faster. By the large packets, even 3 times faster. If we take a look at encryption, yeah, you can get 500 versus 800, and with the small and encryption, more than 2 times better hardware encryption acceleration on 1100 X2. But of course, they run into a problem. His device doesn't perform as expected. Performance not better, even worse, especially on ports Ethernet 12 and Ethernet 13. And the answer is again in block diagram. And the reason is Ethernet port 12 and 13. Ethernet port 13 is management port, and Ethernet port 13 is emergency bypass port. They are both connected through PCI controller, and they are not optimized for the traffic, high-speed traffic, and so on. Best connection to the device that port can have is directly to the CPU, so best port on this device is actually either 11. There's even no switch chip in between. Then goes the switch chips, and this is bypass port, so if the device shut down, this traffic will just go to that port, bypassing that device. And this is simple management port for low traffic on Winbox connections and such things. So the actual traffic stream should go like this. So this will be the most optimal traffic stream. So from one switch chip to another, or from both switch chips to the either 11. So that will be most optimal usage of this hardware by the block diagram. So finally, Dave makes a decision that 1100 X4 is the best hardware that he can possibly buy with all these options that we just mentioned, block diagram. So you can see 2.5 gigabit lines with the new hardware for each dedicated switch chip, and all the boards are connected through the different switch chips. So, of course, with all these problems and all the hardware choices and all the excitement, they've continued to write to the support at MikroTik.com. At this point, we probably create a separate queue for Dave, so that all his emails is in there, and so that we can answer only few emails a day to him, so that it doesn't overwhelm us. But if we go to the performance, you will also see that X4 is much more powerful than X2 and then 750. And if we go to the hardware encryption, we already saw that 1100 X2 was 2 to 3 times faster than 750. This is 2 to 3 times faster than X2. So X4 is faster, has better hardware encryption acceleration than others. So this part of presentation, I really want you to understand that knowing how to use your hardware, you can really improve your performance, and there's no need to buy a new hardware sometimes or write to support. So please check the diagrams of the devices that you use. Check out that you use them properly, and it might even solve some of your existing problems simply by plugging into the right ports your main load. So, okay, so let's go to the software part. Meet Mike. So he's a self-made businessman with a small office that works with customers, with several employees and few servers. Mike is a strong believer in all-in-one solutions. He looks for one network device that does all things. And so he needs an access point for the office devices, guest network for the customers, 5 Ethernet ports to connect some servers, and internet for few PCs. And Mike's friend Dave can't stop talking about MikroTik. So he gets him a hub AC squared. So instantly Dave explains that you need to look at block diagram. So as you can see, nothing fancy in here. You have 2 gigabit line to 5 ports. So you should be able to get full 1 gig if you use on 2 of those ports. You have separated 2 wireless devices, and so on. And of course, Mike jumps right in. He gets the default router OS that was on the device, 40.5. He creates a bridge. So he bridges all the Ethernet ports with all the wireless ports, with all the virtual wireless ports for the guests. And then now he's ready to apply bridge filters to isolate his guests from his servers, so that guests can only go to the internet. So, yeah, sorry. And this is wrong. So what's the problem? So server to workstation speeds on Ethernet is not reaching 1 gigabit per second. CPU load is high. Internet communication is slow. And if we take a look at tool profile, we see the high bridging load. The reason is very simple. Because bridge firewall is enabled, all traffic goes through bridge firewall, and it goes through slow pathway, so regular pathway through the whole packet flow diagram. And basically all traffic is filtered. But if we take a look at 6.41, we have this new nice bridge, hardware accelerated bridge implementation, which combines bridging and switching features. You can actually see this nice table about which features are implemented in hardware on our wiki page. And if we go back to the diagram, you can read that this device uses AR8327 switch. Then you can, then you can go to the table that's on the manual page, find that entry and see that this switch is supported, some switching features in a switch menu. RSTP, STP is also supported, and other features are not supported by this switch chip. But you can hardware offload some stuff with this bridge implementation. So we know about the new bridge implementation. We know about Mike's requirements that he needs to filter his virtual Wi-Fi clients from his servers. In this new hardware offloaded bridge, each port have this new option, HW, so hardware, that you can turn on or off. So if you turn it on and those devices are in the same switch chip, which in that device particular that we use, 750, they all are in the same switch chip, that traffic will not reach the CPU, they will be switched in the switch chip. And that actually can be used by us to force some traffic off the bridge firewall. So you can add, so set this option from some ports that don't need firewall filtering, and they will go through the switch chip, while the rest of the ports will be still filtered. So it's like a filter before the filter. So by simply adding some features like these, you take off lots of hardware from your bridge filters, reduce your load drastically, and best part, hardware switched will work at wire speed without any load at the CPU. So just a simple option, simple planning of the stuff. So now internal devices works with the servers perfectly. Load is normal. But Mike notices that some of the customers abusing the network apply heavy downloads to both to Mike servers and to internet. So he reads that there's such thing as QoS. So what he does, he takes and enables this, my second favorite option after Masquerade, use IP firewall, yes, in the bridge settings, which basically sends all the bridged traffic through the connection tracking, adding enormous load to the device. So, and he creates simple queues for his guests' APs and applies a PCQ on it. So the problem is, first of all, queues doesn't seem to work. But causes additional load. So if we take a look at the tool profile, we take a look at the packet flow diagram, we take a look at firewall logs, we will see that bridge traffic now travels through the IP firewall, including connection tracking. But from routing perspective, guest traffic comes from the bridge interface, not from bridge port interface. So if you use interface as a target in a simple queues, you cannot capture both traffics. You can capture either by setting up bridge port bridge traffic or by setting up bridge interface routed traffic from those clients. But there is a one place in packet flow diagram. So routed traffic going this way. Basically, there's routing over here. Bridge traffic is going this way. And we have one queuing place where you can apply queues, where all that traffic comes together. It's interface queue. So you can actually have a single queue that captures both parts, bridged parts and routed parts of this client traffic. So solution is very simple. Both firewalls, bridge filter and firewall, IP firewall, have a possibility to add a packet mark. Add them there, the same mark, and then use simple packet mark in a Q3, but place that Q3 on the specific interface or bridge port. Then it will capture all the traffic that leaves that, and do not use IP firewall. Use IP firewall in bridge settings. That's a last resort options. It's very specific. And please double, triple check that you really need it, because it causes a lot of load. So with guests limited to the certain speed, Mike looks into what exactly that his network was used for. So he takes a look at DNS cache and notices that there's lots of entries about his competition. So basically, it looks like the customers, when they arrive on their premises, just like to compare prices before ordering something, which is not what Mike's expect when he provided that internet connectivity. And also, he noticed that some of his employees are busy using YouTube and Facebook. So he wants to limit those also. Of course, he gets into the internet, and first thing that pops up is layer 7. And he copies these rules and runs into the problem. So this is completely wrong. CPU is high, there's increased latency, there's packet loss, there's jitter, and the funny thing is that YouTube and Facebook is not even blocked. So you cause all the load, but those bastards are still working. So let's take a look at tool profile, and we will see that layer 7 is very high load. And the problem is with this implementation that was on the previous slide, each connection is rechecked over and over and over again, because you receive it, check it, drop it, then you receive next packet from it, you again check it, you again drop it, receive next packet of it, and so on and so forward, and the roller coaster goes, and routers dies, CPU load is high, watchdogs start to reboot routers, and everything is bad, and MikroTik is crap. So, yeah. To understand what's going on, the problem is basically that layer 7 is checked in the wrong place against all the traffic. So what we need to understand that layer 7 is a method for searching patterns in ICMP, TCP, and UDP streams. And that pattern needs to be checked against some section of the connection. You cannot check it in with one packet. You need to either 10 packets or 2 kilobytes of data to strip the headers off of data in the packets. And then you can search for this pattern. Sometimes one packet will not even match. You will need to collect like 5 or 6 of them to get that. And all the internet, all the patterns that you can find on the internet is usually this size, for this size, not for first packets. So you cannot use drop when you use layer 7. That's a rule. I'm trying now to fight myself through the software implementation. So if you will have layer 7, you cannot choose drop as action. But so far, guys saying that it will basically break many existing configurations. Oh, well, I'm ready to take that hit, if you ask me. So the proper way, but the old style, is to use connection mark. So you take previously unmarked connection, so connection mark, no mark, and then if it matches to your pattern, you add a YouTube, for example, connection mark over here. So you add a new connection mark. So this ensures that if you marked something at least once, you will never recheck it again. So you will check each connection only once, which already improves the thing. Then you can mark packet from those connections, and then you can do whatever you like with those packets. So for example, in here, I just dropped them. So the entry about connection mark will remain in the firewall, in the connection tracking. And you will not, once it matched, you don't have to worry about it again. It will never be matched again. But that's the old way. The new way is to use TLS host, which is basically, for most popular traffic in the internet right now, HTTPS. So basically, it allows you to block or to find the traffic for specific HTTPS web pages looking at TSL SNE extension. And this option uses a glob style pattern. So how it looks actually quite easy. So you now can create rules like these. And with these, you can actually reject the connection. Again, drops. I don't like drops because with the drop, you will have to start again. So reject works much more profound in these cases. And let's say browsers like the rejects much more than they like drops, because with the drops, they will try and try and try and try again. With the reject, they will understand, OK, this one doesn't want to talk to me, goodbye. And that's it. So you will reduce amount of traffic actually by rejecting, not by dropping web page requests, for example. So using the latest features. So Mike is happy with the device, but it's landing a bit high on the load. So layer 7 TLE's hosts. And he reads up and stumbles upon fast track. OK, so instantly he discovers that basically fast track is a feature that allows to add a flag in connection tracking table. So it works for TCP and UDP IP version 4 connections. And it allows traffic from that connection to go the fastpath way through the router by skipping all the other facilities like firewall, queues, and any other. Of course, some packets we need to go the regular way to refresh some timeouts so that connection doesn't get timed out from connection tracking table. But basically, as soon as you fast track connection, it becomes invisible for most of the router OS facilities. So what happens? As soon as he enables fast track connection, the default rules that he finds on the internet, where you fast track everything that reached connection state established and related, and then accept it, his layer 7 patterns and TLS host just stopped working. Why? Because basically both of those options require several packets to match the fields that's required. So layer 7 and TLS host both require several packets to match that pattern that you gave, but you are fast tracking starting from second packet. So, but it's not white or black like everyone thinks so. So I cannot use fast track. No, you can use fast track. You just need to do that a little bit smarter. Just fast track everything starting from 11th kilobyte. So the first 10 kilobytes will go the slow pathway. It will match your layer 7. It will match your TLS host. It will do something else. And after that done, you can easily use the fast track connection. So you don't have to make it black or white. Either you can use fast track or you can't use fast track. There's a middle way, and the middle way is the best one, where you can choose what features you want and what features, what you are ready to give up for the more performance out of the device. So Mike's business is booming. He opens few more stores. Of course, now he needs to interconnect his stores with a secure VPN. So the devices must be in the same subnet because the servers work that way. And he needs a high throughput. So as usual, let's go back to my first favorite option, Masquerade. So he has many offices, and each office is masqueraded. And as soon as he tries to make an IPsec tunnel through it, that IPsec tunnel simply doesn't work. The idea is very simple. The IPsec packets are rejected, and tunnel cannot be established. And if you sniff that traffic, you will find out that your NAT rules, your masquerade rules, are changing source address of encrypted packets, and that doesn't correspond to the IPsec policy anymore on opposite side, so it gets discarded. So you need to find some way how to allow your basically allow your IPsec traffic to skip basically nothing. You don't need nothing for that traffic. So you can, what you can do, you can create an accept rule before your masquerade rule, right? But that will not benefit you because it will still go through the connection tracking and will cause additional load, and you created additional rule. So that also causes additional load. The solution is to use a raw table. So a new table that was added to the firewall, which allow you to select traffic that bypasses connection tracking. And when you bypass connection tracking, many good things happen. First things, packets don't get defragmented back to the whole packets. So you can send fragments through the device. So it doesn't require reassemble by connection tracking. NAT will be skipped. And some of the options that requires advanced connection tracking features like mark connection, fast track connection, layer 7 will not work anymore for that traffic. But the regular options like source, destination IP address, and most used options will still work quite fine in firewall. And this traffic will have connection state untracked. So if you add two raw rules that accepts, basically adds action no track, that means skip the connection tracking. To the raw table, your IPsec tunnel traffic will not reach the NAT and will just be passed through in quick manner, skipping connection tracking, so it actually will work quite fast. So then, of course, Mike needed to securely bridge to networks. So the first implementation that he came up with is to run layered L2TP and run Ethernet over IP over it, which was fine like 10 years ago, okay, 5 years ago, I would say. Currently, it's wrong for many reasons. So first of all, there's double header. That web pages opens very slowly, slow download speed, and also this is very unsecure. Basically, it takes seconds for somebody with the right equipment to get into that L2TP and PPTP connection. So, strange suspicion that competition knows your secrets. So, you can diagnose that with bandwidth test tool, with ping tool, with different sizes of packets and without fragmentation bit. And the idea is very simple. Don't use PPTP, L2TP anymore, not at least not in a plain way. The only way how to properly implement tunnels right now is with IP security. That's why we're coming out with the hardware that have IP security acceleration units on them, and so on. So you can take a simple Ethernet over IP tunnel and turn it easily with one option into secure IPsec tunnel. Just specify IP secret option in the tunnel settings, and that's it. Your tunnel now is an IPsec tunnel, but it works as an Ethernet over IP. So you get all the benefits. So, yeah, just to remind you that we have lots of hardware coming out with IPsec acceleration, and please check that performance tables before you purchase equipment or you implement some specific setups on the equipment. So I hope I get at least some of my points across and solve at least some of your problems. So for me, that's it, is it. Do you have any questions? Okay, then, thank you.